Hi everyone, welcome to DevSphere. So today we are going to look into AEM as a headless CMS and how to design an efficient caching strategy for better performance and scalability. So before we start, it is essential to understand what does headless mean. So when we are using AEM as a headless CMS, content is delivered through API. So these APIs can be either REST APIs or GraphQL APIs. So it's not using the traditional AEM templates. Instead, it is using APIs, and hence we are saying that it is a headless CMS because it doesn't have a head or a client. So in this approach, client can be anything. It could be React.js or Angular framework or any other front-end technology for that matter. This API approach, however, introduces challenges like increased server load, latency, and real time content updates, and hence it is very important to have an effective caching strategy. So let's take a look at the sample implementation. Here we have front end written in React.js. It interacts with microservices for any sort of integration, even for AEM. So here we have a content service which is called content microservice, which calls different AEM REST endpoints. So this microservice can call different endpoints and then collate this data through GraphQL queries and return back to the front end. So now if we just focus on these REST API endpoints from AEM just for the purpose of this video, then it all starts with understanding the requirement from front end, designing the contract of the API, then creating content fragment models based on the contract of the API, and then finally having a servlet in AEM to export this data in the JSON format. So now if we see at what all levels caching can be done for these AEM REST endpoints, then first layer we have is the dispatcher layer, which provides out of the box caching. And then on top of that we have CDN or Akamai layer, which provides another caching layer. And then these content microservices can use Redis cache. So I'll go in detail as to how these layers can be leveraged. But before going there, I would like to give you an example of the few endpoints that can be used. For example, if we have to list down the products configured in, let's say, my project, then I can have an endpoint something like this, which will list me down all the products in the format of JSON. Then in this case, servlet will pick the selector detail and it will output the JSON as per the requirement or the contract defined in the API. Now let's say if you have further requirement that you have to list down these products for a particular brand X. Sorry for the typo here, it should be slash, yes. So then I would suggest extending the path parameter rather than having a query parameter, because with this approach it becomes easier to do the caching and also invalidating the cache. So you can extend the path with brand X as shown here. Moving on further, let's see why caching is important for us. So caching reduces response time because it avoids unnecessary API calls going to the AEM backend server again and again, and hence response times are better if it is cached. Also with caching, it is able to scale effectively because now server can handle more number of concurrent requests. Also, it improves reliability. For example, let's say your APIs are cached in Akamai and for some reason your dispatcher goes down, then there will be no impact on your website because the content will still be able to serve from Akamai cache. As we briefly touched upon earlier, now let's see in details what are the different caching layers that we have. So first one is dispatcher caching. So this, as you all know, it is the out of the box caching which is available for AEM. So we must use as much as we can for the dispatcher caching. So for dispatcher caching, you can cache static assets like images, CSS, JavaScript files, and also you can cache API responses. Second is CDN caching. CDNs like Akamai or AWS CloudFront, they're very essential for distributing content closer to the end users. So you can cache frequently requested API responses at edge locations, or you can implement path-based caching. For example, in the endpoints that we have seen a few slides before, the product endpoint, we can cache it for let's say 24 hours because these products will be getting added less frequently. And if there is an endpoint called product details, we can cache it for 1 hour because there might be frequent changes in the product details endpoint. Third layer is Redis cache. We can store REST as well as GraphQL API responses in Redis along with unique keys, and you can define TTL for these API responses. So based on TTL, these responses will be invalidated. And since Redis has distributed architecture, it is very helpful in scaling based on increased traffic. So now we have seen how caching can be done. Now let's see how invalidation can be done for each of these layers. For dispatcher, we can configure AEM flush agents to clear the API responses. And for that, we can use ACS AEM Commons dispatcher flush rules. So whenever there is a change in any of the content fragment, corresponding API responses can be invalidated. For CDN or Akamai, a very effective and simple way is to define TTL. So for frequently changing data, like we discussed before, for example, product detail, we can have a shorter TTL, like an hour or so. And for less frequent updated data, like products, so we can have a longer TTL for those, for example, like let's say 1 day or 24 hours. Now moving on to Redis. For Redis, we can follow the same approach as we have done for Akamai, that is using shorter TTL for volatile data and longer TTLs for static data. But it is very important to define the same TTL as you have defined in Akamai. This is for consistency across different layers and for a consistent user experience. And what I mean by that is, let's say in your Akamai TTL is defined as 1 hour and in Redis it is 24 hours. So once it gets expired in Akamai after an hour, your changes will still not be visible on the front end because the data is still cached in Redis. And unless it expires from Redis as well, users will see inconsistent content on the website. Hence, it is very important to have a consistency across different layers for caching. So we have learned today that a well-optimized caching strategy is very important for AEM as a headless CMS, as it ensures balance between performance, scalability, and content recency. Also, we can leverage caching at multiple layers like Dispatcher, Akamai, and Redis. And alongside a good caching strategy, it is very important to have caching invalidation strategy as well, so that we have a consistent user experience on the website. So that's it, guys. I hope you liked the video, and if you liked it, please press the like button and comment down below if you have any comments on the video or if any suggestions, they're all welcome. And please do not forget to subscribe the channel. Thank you. See you in the next video.